Alright, today we're going to talk about patterns in nonlinear functions. Okay, last time we talked about actual linear functions and everything. Let's make this green. There we go. Nice green color. Okay, patterns in linear functions, they should follow a pretty strict guideline. Alright, so you should have your table. Let's say we had our table values. Now if you're looking at a graph, it's really easy. Like, oh, does that make a line? No? Then it's not a linear function. That's the best thing about it. But looking at tables and then actually looking at the actual function itself, that's going to be the hard part. Okay? Alright, so the information, let's say we had 1, 3, and 2, 7, and 3, 9. Okay, let's say we had something like this. Okay, so basically what we would do is we'd look at the information and see if it's increasing at a constant rate. In other words, both of these numbers should be the same. So this should be a +1. We're increasing by 1 each time. That makes sense. Okay, this one would be a +4. Okay, and then this one would be a +2. So since that's a +2, that's not constant. It's actually decreasing, so this is non-linear, whatever the function is. Okay, so that one's pretty simple. Another example is how to look at the function. So if we have it in the form of y equals a number times x plus or minus another number, that is linear. Okay, if we have something that looks like this, y equals x squared, or any kind of variation, ... you know, that is non-linear. Okay, now if this is the highest degree, that is actually called a quadratic function. Okay, if the highest exponent is going to be 3 plus blah blah blah, okay, that's actually cubic function. That's non-linear. Okay, if we had something that looks like the absolute value of x, okay, that is absolute value. That is not linear. Okay, if we had something that looks like the square root of x, alright, that is a square root function, and that's non-linear. And let me see, is there anything else? No, that's pretty much it lined up. Okay, so once again, look at the table. If you have constant values, you're linear. If you have non-constant, you're dealing with non-linear type of functions. So as long as you know that, you should be fine. I mean, it's just going to make your job a whole lot easier. Just take a look at the constants and just work with them and make tables whenever you can. Use tables, or if you want, you could actually take those tables and you could graph it on there. So, for example, let's make our own table. Well, you could actually just graph them. So what was it? It was 1, 3. Okay, and then we just graph 2, 7. Okay, we'll have to zoom out a little bit. Excuse me. Alright, and that looks linear so far, but you have to remember your rules from geometry is that, yeah, 2 lines can make a linear pair. 2 lines almost always do. So you have to be careful. So if we take a look at this one right here, these two line up, this one does not, so therefore non-linear is how I'd graph that. And just take a look at that, okay? Alright, so that's it for patterns in nonlinear functions. Thank you guys and have a great day. Bye.